Alright, so let's do another example problem for making standard stereographic projections. And if you haven't looked at the previous videos, I'd recommend checking out the problem 1 and 2 and then coming to this point. And you could even practice this by yourself on a WolfNet that you might have a printout of. Alright, so the question here given is we have to draw a 0, 1, 0 standard stereographic projection, which is similar to the example 2, but the difference is now the pole that we have, the other pole that is given is 0, 0, 1 on the S point, which is the south point. So we're going to be following these steps again, and if you follow these steps, you should be able to finish the entire stereographic projection with all the correct poles. And just to reiterate the family of the poles that we are dealing with, we have the 1, 0, 0, which is given as a square, then the 110 family of poles, which we'll give as an ellipse due to the twofold symmetry, and then the 111, which we will give as a triangle. So this is a fourfold, twofold, and then threefold. These are symmetries, and these are the notations that we'll use. And keep in mind the families might include this one going to either any of these places and also having a negative sign, and all the possible combinations. All right, so let's follow the steps again and let's fill this up. All right, so the question asks us to draw a standard stereographic projection of 0, 1, 0. So that will go in the center. So this becomes 0, 1, 0. And then it tells us that the south pole is 0, 0, 1 pole. So the south pole is over here, and they tell us that this is a 0, 0, 1. So this becomes 0, 0, 1. All right, that was the first two steps. Now the third step is to find the axis orientation. So let's figure it out. The one at the very center is the axis that points outward. So if I draw the XYZ orthographic orthonormal axes, we'll have the XYZ, and the one that comes outwards. So here, actually let's draw the outward first. So we have the 0, 1, 0 coming outwards. So we have the 0, 1, 0 coming outwards, and then as you will see, this is XYZ, so this will be the Y axis, and then the south pole is 0, 0, 1, which is the Z axis. So this over here is the Z axis, which means that the one at the top would just be the minus Z axis, and this is 0, 0, 1. And that tells us that the x-axis would be on the right hand side, given that the x cross y should give us the positive z, which is the downward direction. So the x-axis will just become 1, 0, 0. All right, so with that, now we can mark the rest of the axis. So as we said, the east point will become, so this is the east, this will become the positive x-axis. So the positive x-axis is 1, 0, 0. And then now, once we have these filled up, we can fill the opposites. So the north pole will just become the negative z-axis. So that is 0, 0, bar 1. The west will have the negative of the x-axis, which just becomes bar 1, 0, 0. Right? And we have filled up all the 1, 0, 0 family of poles. Now comes the 1, 1, 0. So for that, so we start with all the internals bisections, and then we'll do the outermost greater circle, and then we'll join them. All right, so let's start counting from the center, 45 degrees. So we'll have 10, 20, 30, 40, 42, 44, 45. And then this should be just the vector summation of the north and the center. And this will give us 0, 1, bar 1. And then the one on the right will be 10, 20, 30, 40, 42, sorry, 10, 20, 30, 40, 42, 44, and then 45 right here. So this will be the vector summation of the center and the east. That gives us 1, 1, 0. And then the one on this side will be 10, 20, 30, 40, 42, and 44. Summation of center and the south. So this gives us 0, 1, 1. And then the one on the left will be 10, 20, 30, 40, 42, 44, 45. This will be the summation of center and the west. That gives us bar 1, 1, 0. Just to avoid any confusions, I'll rewrite this. So this is bar 1, 1, and 0. Alright, so we have the internal ones marked. Now we can do the one that is on the outermost great circle. And I'm just following the steps that we wrote above. So I would recommend you to follow that as well to avoid any confusions or to prevent any missing poles. Right, so let's count maybe in this clockwise direction from east. So we have 10, 20, 30, 40, and then 45 as summation. So this just becomes 1, 0, 1. From the south, it goes 10, 20, 30, 40, and then 45. Summation of west and the south, that just becomes bar 1, 0, 1. And then from this side, 10, 20, 30, 40. And then over here becomes summation of north and the west. So this just becomes bar 1, 0, bar 1. All right. And here with this, we have filled up all the twofold axes that will be, and the twofold poles that will be present in the stereographic projection. Now for the last one, where we have the threefold, the 1, 1, 1 family, let's try to fill those up. And if you remember, the easiest way to, oh, I realize that we've missed one of the poles here. So we'll fill the east. So we'll go from 10, 20, 30, 40. And then this will be the summation of the north and the east. So that gives us 1, 0, bar 1. Now the next step, as we had discussed previously, would just be to join the poles that are on the outermost great circle. So we'll draw a straight line that passes these 2 points, but then also passes through the center. I'll recommend using a ruler for that. I'm gonna do it freehand just to demonstrate. All right. So with this, now what we can do is we can find the great circles of this pole and this pole, and then see where that great circle intersects these two diagonal lines, and then mark those as the 1, 1, 1 family. All right. So let's draw the great circle of this 1, 1, 0. So this will simply follow the middle point of the 42 and 40, the 44 and the 46, and then it will go all the way down, and then same thing over here. Now the reason we are doing this is because the 1, 1, 0 that we first wrote is at 45 degrees from 0, 1, 0. So the idea is that any point on this entire great circle that I just drew is exactly at 45 degrees from 0, 1, 0 from the center. And same on the other side, the bar 1, 1, 0, we counted the 45 degrees. So if I draw the great circle for this, any point on this entire great circle is at 45 degrees with respect to or from the center. All right. So now, as I said, we can find the intersections of this with the diagonal lines and mark those as our 1, 1, 1 family of poles. So this is 0, 1, 0 vector sum with the 1, 0 bar 1. This will give us 1, 1 bar 1. And I'm using the triangular notation to denote the threefold symmetry. The next one on the left hand side, the center and the outside sums up and gives you bar 1, 1 bar 1. The one on the left and the bottom half of this wolf net will give you the sum of bar 1, 0, 1 with 0, 1, 0. We are doing a vector sum. So this just becomes bar 1, 1, 1. And then the one over here becomes the sum of 1, 0, 0, 1, 0 and 1, 0, 1. And that gives you just 1, 1, 1. All right, and this is all the major poles. So all the major poles in these families that will exist on this side of the stereographic projection, where 0, 1, 0 was in the center and 0, 0, 1 was in the south pole. So this should be the final answer. Go ahead, try following the steps once more, and you can use that to practice all the example problems, and then maybe note these steps down if it helps, or in your own words in your cheat sheet to help with making these stereographic projections. Now, the next question that we'll basically take something like this and then do more sub questions. So, other than just making the stereographic projection, we'll also figure out how to add other poles to this, or how to calculate angles between. So for example, if someone asks what is the angle between bar 101 and 101, or any of these poles or any other poles that are provided to you, if there's a question of ask the angle between the two poles, or so if someone asks you along with the stereographic projection, if you're asked angle between poles through this wolf net, or if you are asked to calculate the trace of a pole on this wolf net, or if you are asked to calculate the zone axis of two poles, how do we do all these? And then also I should add, this is something we already did, but just to practice we'll take some more examples. So we'll see how we can mark new poles, find angle between poles, draw the trace of a pole, and then find zone axis of two poles. Alright, so that will be the next video. This is the final answer for this clip. Thank you.